Hey everybody, my name is Ben and I love math, and this is Ben Loves Math. How you doing? You doing good? Alright, let's get started. This is a long packet of notes, but a lot of that's because these problems take up a lot of space to write them out with the tables and everything. Day 2 notes. Day 1 we talked about scatter plots and lines of best fit. Mostly linear stuff. Now we're going to be talking about curves of best fit for parabolas and things. So we've got lines and we've got curves, and there are actually more curves than just this type of thing, but we're going to talk about just your linear and your quadratics today. Again, remember that linear regression is the math that's used, that your calculator uses to come up with this line of best fit. Quadratic regression is a similar type of math that's used to come up with the quadratic curve of best fit. So you're going to be able to use your calculator to find a curve of best fit from a table or a scatter plot, and then you're going to make predictions using your equations from either lines or curves. Predictions, I mean, that's really the main idea behind math, is being able to calculate what things should be or might be in the future. That's how we are when we build bridges. We know they're not going to fall apart, or how we know that each phone that's made is going to react the same way, or whatever. You need to be able to have predictions, and that's based off of mathematics. All right, so yesterday we did all straight lines. What if the data does not look like a straight line? I want you to go ahead and enter this in. I want you to go to y equals and zoom 9. Make sure your stat plot is turned on, and make sure any equations are turned off. I'm going to pause my video and put these numbers in and plot it real quick. Actually, I've decided to do it while recording. Remember to clear your list. I don't know, can you all see that? We're going to go up to our list name, hit clear and hit down, and that clears the list out. Now I'm going to enter the numbers in. Then I'm going to go to y equals. I'm going to delete any equations that I have, and I'm going to make sure that plot 1 is turned on. Now I'm going to go to graph, and then I'm going to go to zoom 9, zoom stat. And you can see here that we kind of have a curve. It looks like a parabola. All right, so now to find the best fit, we're going to go sort and then write 1 to the calc tab. Instead of going to linear regression, we're going to go to quadratic regression, quadreg. Okay? Enter, 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 calculate, and that's going to give us an A, a B, and a C. So A is negative 2.9, B is 42.9, and C is negative 70, call that 3. And we're just going to plug these in for A, B, and C in our quadratic. So y is equal to A times x squared, so that's negative 2.9 times x squared, plus B times x, which is 42.9 times x, plus C. Instead of plus, we're just going to write minus 73 because it's negative. And we're going to quickly go back to y equals, and we're going to graph this. Negative 2.9 x squared plus 42.9 minus 73. Uh-oh, mine doesn't look right. What did I do wrong? I didn't put an x. I put plus 42.9, but I did not put x. Second insert x, enter, graph. There we go, much better. That scared me. Whew. Feel so much better now. All right, so that looks good, right? It goes through the points, kills a lot of zombies. Very good. So the main idea here is just that we're going to use quadratic regression when it's a curve. Linear regression when it's a line. All right, your turn. I want you to answer these questions. I've already answered it on this page, so I want you to pause the video, go through answers. The data linear or quadratic? What is your equation? And show anything that you need to show. Pause it, come back when you're done. Welcome back. So it is quadratic, obviously, because we're working on curves of best fit. We're going to use quadreg. I just wrote that down just to remind you. Found our A, B, and C, and then we've got to plug it in our calculator, our A, not our calculator, into our formula. A, B, and C. Negative 0.6 x squared plus 5.1 x minus 4.3. If you have questions on this, now's the time to ask. I'll probably put this on an ed puzzle and have you answer some questions too on that. So, on this next problem, and I don't know why I did this ahead of time, but I did. Make the notes go faster, I guess. You need to find the coordinates of each of the points. I went ahead and made a table, and I put my coordinates into the table. 1, 1, 2, 3, 4, 5, 6, 10, 8, 7, and 9, 4. You don't have to do that if you want. I just like the way it's organized.
Andrea Lanusa, please come to the main office. Andrea Lanusa, please come to the main office.
I'm just getting quiet while they make the announcements. And then I plugged this in my calculator. I found my A, B, and C. Negative 0.3, 3.9, and negative 3.2. Use the equation. And now here's the difference. It says find the value of y when x is 4. I have a 5 written right here. So I'm just going to go ahead and do them both because I don't know which one I wanted. F of 4 is 7.6. I did that by plugging 4 into the equation. Negative 0.3 times 4 squared plus 3.9 times 4 minus 3.2. Or you could put this equation into y equals on your calculator, and then you can go to your table. Or you can use the value function on your calculator to find that value. So what did we do? We found the points, put them on a table, put them in our calculator, found A, B, and C, and then we plugged 4 in. Or if you plug 5 in, I got 8.8. So I can plug it in, or I can look on the table on the computer. All right, here's a word problem. A student who waits tables at a restaurant recorded the cost of meals and the tip left by the single diners. Meal costs and the tips left. By the way, these are low tips. When you go out to eat, be sure you tip more than these people. What is the line of best fit equation? So, I don't think you need to watch me do this. I'm going to enter this data in, and then I'll come back. All right, so I've got my data entered in. I want to go to my graph. Oh, I do not want that parabola there. That's from the last problem. I forgot to delete that. So let's delete that last parabola. Let's go to my graph. I'm going to go to zoom, stat, zoom 9, and that looks linear to me. Okay, so before you do a quad reg or a line reg, you've got to go look at the graph to figure out, is it a line or is it a curve? If it's a line, then we need to go to stat right number 4, line reg. And I get that ax plus b, a is equal to 0.16 and b is equal to negative 0.3. So 0.16x minus 0.3. All right, so it asks, what if we had a meal for $10.50? How much should we tip the waiter? How much should we tip the waiter? All right, so what variable are we given? We're given a meal costing $10.50. Which one is that? Well, the meal cost is X. So we're given X. It's asking us for how much the tip is. The tip is Y, so we're looking for Y. So we're given that X is equal to $10.50. So we're going to plug that into our equation. Y is equal to 0.16 times X is equal to $10.50 minus 0.3. And it says solve. In this case, it's already solved for y, but we got to figure out how much this is. 0.16 times 1050 minus 0.3, and the tip should be $1.38. Okay, so what did we do? Enter the stuff in. I looked at it, zoom 9, found out it was linear, so I did a line reg. Plugged in 1050 into the new equation and found the y. Sometimes though you're given y and you're asked to look for x. The next 3 examples I have already worked out, so I want you to pause the video, do number 2, unpause it when you're done. Come back and check your answers. All right, you ready? Welcome back. Number 2. Plotted these, looked at it, it was linear. I did my line reg and got y equals 6.1x plus 63.9. We're given the variable x. X is equal to, where are we? Here. Studied for 6 hours, so x is equal to 6. We're looking for y, so we plug in x, I did my math here. You can double check it if you want. And I got that if you study for 6 hours, you'll make 100.5%. That'd be a pretty good grade. I'd be proud of that one. Much more proud than all these cheap tippers. Tip more. Tip your waiters and waitresses. They need it. All right. Pause the video. Go ahead and work number 3. Come back when you are done. Welcome back. Number 3. Enter the stuff in. I looked at it on the graph. Looked at my scatter plot. Did zoom 9. Saw that it was linear. Did a linear regression and got 0.42x minus 19.8. If a man has a shoe size is y. X is always first, y is always going to be second. So y is equal to 10.5. So that means we need to plug it into our equation on the left for y. 10.5 is equal to 0.42x minus 19.8. So from this point, I plugged it in, and now I have to solve for x. So we're going to add 19.8 to both sides. That gives me 30.3 is equal to 0.42x, and then we divide by 0.42 and get that a man who wears a 10.5 size shoe might be around 72.1. We didn't have units over here, but I don't think he's 72 feet tall. Definitely not 72 meters tall. 72 millimeters would be about this big, so I'm going to go with inches. So that's 6 foot and just a little bit more. All right, number 3 is done. Number 4, pause the video. Work number 4. Come on back here when you're done. Welcome back. All right, what do we get here? So I did not do a linear regression here. This is obviously a line. And if you wanted to, you could have found the coordinates for these points. But the line goes straight through the point, so I'm able to just go ahead and find my M and my B. My slope is up 10 and over 20. 10 over 20, or 1/2. My B goes through the origin. That's a 0. So my equation is y equals 1/2 x plus 0, which I don't have to write the plus 0 because it doesn't change the value. And now what do I want to do? I want to say that what is the minimum number of bags to make $200 profit? Well, $200 profit, that's y. Y is equal to 200. So we're going to plug that in for y into our equation. 200 is equal to 1/2 x. 200 is equal to 1/2 x. And now we're going to solve by dividing both sides by 1/2, and you get 400 is equal to x. So you sell 400, that shouldn't be dollars, 400 bags of popcorn, and you'll make $200 profit. Got it? So those were all linear. Now let's do some Kerber best fit prediction problems. The thing is the same. You're going to plug in the data, find your curve of best fit equation, and then plug in some numbers. For your purposes, you're only going to have to plug in x. For the linear ones, you might have to plug in y. But for the quadratic ones, you're only going to have to plug in x. X is 5 for this case. So what is the curve of best fit? I'm going to pause this and what am I going to do? I'm going to pause this, work this one, and come back. So I've put it in my calculator and plotted it. It's definitely a curve. So I'm going to do a stat to the right 5, and I get y is equal to negative 16x squared plus 82x plus 0. So I'm not going to write the plus 0. What variable are we given? We're given x equals 5. We're looking for y. So we're going to plug in 5 for x. And we're going to get, y is equal to negative 400 plus 410, which is 10. Y is equal to 10. Or you could plug this in on your calculator. All right, moving forward. I've already done examples 2, 3, and 4. Pause it, work number 2, come back, check your work. Just do one problem at a time. All right, go ahead and pause the video. Welcome back. I plugged these numbers in for x and y. Found my a, b, and c, 1.7, 2.9, negative 5.2. I plugged them in, and then defined y, or f of, I'm sorry, I didn't see that negative sign there. That is going to change things a little bit. Let me redo that math. 1.7 2.7 parentheses negative 10 close parentheses squared plus 2.9 parentheses negative 10 parentheses minus 5.2 is f, I'm going to write this as f of negative 10. The value of the function when x is equal to negative 10 is 135.8. All right, pause the video. Redo number 3. Come on back when you're done. Welcome back. All right, x and y. We want to know what happens to y when x is 55. Well, I plugged in these numbers. I looked at the graph. It's definitely a curve. And we're doing curve of best fit anyway. Plugged in 55. And found out that when you're going 55 miles per hour, the skid mark would be 105.6 inches long. Of course, these are estimates. These are estimates. These are guesses. All right, but those are good guesses. All right, pause the video. Do number 4. Come on back. Welcome back. Plug these numbers in. I got y is equal to negative 54.8 x squared plus 56x plus 2.7. It's definitely a curve. We're given x is equal to 0.8. So I plugged in 0.8 for x. And I got that when time is at 0.8 seconds, the ball is going to be at 12.428 feet. I guess you could just write like 12.4 feet. Or even just 12 feet, but that's the general idea. All right, so what are we doing? We're plugging it in. We're looking at the graph to see if it's a line or a curve. We're using regression to find our equation, and then we're plugging in our variable and solving for the other variable. It sounds like a lot of steps, and it's not. You just need the repetition, which you are going to get on your practice. All right, make sure you ask any questions to get understanding, any and all questions that you need. I'm out of here.